we're going to look at the properties of exponents part 2. And so the first property we're going to look at is the power rule. And so we're going to write this out as repeated multiplication. So if I take x squared and I cube it, I would really have x squared times x squared times x squared, which is x times x, x times x, x times x is x to the 6th power. So that was 2 times 3. So the general rule, when you have a base and you've got a power raised to a power, you actually multiply those two powers together. So the power rule says when raising a power to another power, you multiply the exponents. So let's practice that property. So this one would become x to the 24th. Number 2, 3 times 7 is m to the 21st. Number 3, 12 times 12, a to the 144th. And number 4, 0 times 5 is 0. And who remembers what anything to the 0 power is? Anything to the 0 power is 1. So 1 is actually my final answer for that problem. What about the distributive rule? So the distributive rule, we have it for products and quotients. Anytime that you have a exponent on the outside, you're allowed to distribute it to both terms inside the parentheses. So a to the n, b to the n. So if I distribute this squared, I actually have 3 squared x to the 6th or 9x to the 6th. For quotients, I have a to the n over b to the n. So I would have x to the 6th over y to the 12th. So the distributive rule says if an exponent is applied to a single term in parentheses, the exponent must be distributed to every part of the term. So we're going to try these 4 examples down below. You could always pause the video and try them first. So number 1 would be x cubed, y cubed. Number 2, I'm going to do 2 squared first and actually make that 4. So now I'm doing 4 cubed, and I know that 4 cubed is the number 64. And then I would have, oh, this is a big number, 3 to the 12th. 64 times 3 to the 12th. When it's just a number, you can actually evaluate it. So 64 times 3 to the 12th power is a big number. 34, 12224. So 34 million, that's a lot. And let's see, what is 1/2 times 1/2? 1/4 m squared. And I would have b to the 8th, c to the 24th. Just remember that you have to distribute it even when there's no additional exponent, because the exponent would be 1. So that's why 1 times 8 is 8, and 3 times 8 is 24. All right, have you ever seen a negative exponent before? So something called the negative exponent rule takes the reciprocal of the original expression and makes it a positive exponent. So if it starts like in the numerator, you move it to the denominator to make it positive. If it starts in the denominator, then you have to move it to the numerator to make it positive. So a negative exponent is not happy where it is, and you move it either to the top or the bottom to make it happy again. So why? So I want to show you what it looks like when you use repeated multiplication. A times A times A, A. Cancel, 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 cancel. I get A on the bottom. So 1 over A is what I have left. So what if we use the quotient rule? Remember the quotient rule? You can take the numerator's power and subtract the denominator's power. Wouldn't that be a to the negative first? So if these two things are equal, see how the negative exponent just moves it to the denominator to make it positive? So 45 to the negative first is the same as 1 over 45. X to the negative second is the same as 1 over x squared. So the rule is When something is raised to a negative power, you change the line. Oh, I should say cross the line and change the sign. So crossing the line, the fraction bar, right? So I crossed the line and changed the sign. So if I was going to simplify this expression, this would become 1 over 8. On number 4, this 4 is currently a positive exponent. It's 4 to the first power. So the 4 is going to stay in the numerator, and c cubed is going to go to the denominator. 1 over y to the 7th. This one's going to become g squared. So it's in the denominator. It's going to cross the line and change the sign. Both of these are going to go to the denominator. So 1 over 3m. This negative is just going to make the answer negative. This negative is going to make just this one term cross the line. So I'll end up with negative 2x b to the 4th all in the numerator when I'm finished. All right, and then the last new property for today is called the zero exponent rule. I know you know already what it is, but why? So the general rule is that anything to the 0 power is always 1. So why is that? So let's simplify the following using repeated multiplication and canceling. So there's my a cubed again over a cubed. Cancel, cancel, cancel. Anything divided by itself is 1. Well, what about the quotient rule? The quotient rule says I can subtract numerator power minus denominator power. 3 minus 3 would be 0. So if these are the same problem, then a to the 0 power has to equal 1. So anything to the 0 power is always 1. So in this case, this whole thing is being raised to the 0 power, so it is 1. This whole thing is being raised to the 0 power, so it simplifies to 1. So now you're going to take a look at the 349 guided practice. It's front and back, so you got 21 questions that you were going to practice all your exponent rules on. Thank you.